Okay, so we're quite familiar now with this graph. Basically, this is the real life graph where we saw that at time equals 0, the man was at 1 meter, time equals 0.33, he was at 1.5, etc. Okay, so this is the graph where we converted the millimeters, distance from the edge in millimeters, which wasn't real life data, into something real life, more real world application. Now in this video what we want to show you is that, actually I'll just look at this statement here. They say in your textbook, it says, we want to show that the choice of origin is arbitrary. Okay, what does that mean? It means that we can shift the position, the origin of the position, and we can shift the origin of the time. Now, okay, let's just show this quickly. We know that originally the man was, if that's your reference frame, the man was 1 meter from our chosen reference frame. So that means at the beginning he was already at 1 meter. Okay? He was 1 meter. In frame 1 he was at 1 meter. How about we say rather, let's make the man himself the reference position. So that means then this horizontal axis will shift up to there. So that is now x equals 0. All we're doing is we're changing the reference position. You can actually put the reference position anywhere. Okay? If you put the reference position there, for example, then the man will have a negative position. Or if you put it there, you would increase his position at the first instant. Okay? Basically what we want to do is we want to show you that when it comes to relative position, this doesn't mean anything. It doesn't change anything if you change the origin. Okay? So we put the reference point at the man, which means now at the first instant he is at 0. Now another thing that we can do is, and what they do in the textbook, is they say, well, how about instead of saying that our first frame is at t equals 0, how about we say our first frame is at t equals 0.33? We're also, in the same way that we're just changing our reference position, we can also change our reference time. We can start at 0.33. Okay? So now you're saying, but this is craziness. Okay? This is absolute madness. So we've changed our reference position and we've changed our reference time. So the man is starting in frame 1, his position is 0. And in frame 1, his time, we're starting at 0.33. And he's saying, why would we do this? Well, the point here is to show that it does not affect relative positions. Please pick this up. Please pick this up. Relative positions. Yes, the absolute numbers and times have changed, right? This first point was originally t equals 0 and x equals 1, and now it is t equals 0.33 and x equals 0. So these points, their values have changed, yes, but the relative positions between these points have not changed. So let's illustrate this. If we take a look at this first point and this maximum position here, so this initial position and maximum position, what is the change here? What's that change? Well, if that's 1 meter and that is 4.8 meters, we know that the change between minimum and maximum is 3.8 meters. So now in this one, what is the difference between the minimum and maximum position? It's 0 here and 3.8 there. So that's also 3.8 meters. Okay? So this is just an illustration. The changes between the positions themselves have not changed. The relative positions have not changed. Also, just because we've started at 0.33 seconds doesn't mean that the time differences have changed. the time differences are also the same. The relative time hasn't changed either. Okay? So this is just a quick illustration to show that if we change the origin, the values do change, but the relative positions do not change.